Hello everyone, my name is Zhang Shuhan, and now I will introduce the method that I use to solve the question 2 on homework 5. In question 2, we have the density functions of xy, which is equals to this. And also we have the area of y and x. First, we need to find and draw the non-zero definition region of xy. Since we have these conditions, which is 1 over y smaller than x and smaller than y, first we look the right part, x is smaller than y. First we draw the line which is x equals to y equals to x. Since y is larger than y, so since y is larger than x, we take the left hand of this of this line, and then we look the left part, which is 1 over y smaller than x, and we can do a trick to these functions. We can get y is larger than 1 over x. And first we draw the line of y equals to 1 over x, since y larger than this, and we take the right hand of this area. So these two areas will converge at this shaded area, which is also the non-zero definition region of density functions fxy. The second is to find a, the constant a, so that the density function is a valid joint density function. And we take the property of the density functions, which is when we use integral of density functions, the final result will equal to 1. So we can write these functions, and then we need to get the upper and lower bound of x and y. First, let's look at the conditions that mentioned in the questions. Y is larger than 1, so we can directly write the lower bound of y equals to 1 and the upper bound equals to plus infinite. Then we can also write the region of x, which is y smaller than 1 and larger than 1 over y. And we can get into this step, and we can do some calculations to x and y, and we get here. In order to solve the integral of ln y over y squared dy, we need to do some tricks. First, we let t equals to ln y, so that the y will equals to e to the power of t. And we can rewrite this integral with parameter of t. So this will be easily to solved, and the final result is a equals to 2. The third question is to find and draw the marginal density functions of x and y. First, we also apply the density functions property, which is fx equals to the integral of fxy to the integral of y. And then we also need to find the upper and lower bound. But in these conditions, we need to compare these two equations. The larger one will be the lower bound. So if x is smaller than 1, the 1 over x will larger than 1 and also larger than x. So the lower bound will be equals to 1 over x. And then we do the calculation of these integral functions, and we get the density functions of xy density functions of x equals to half 1 over 2 when x smaller than 1. If x is larger than 1, and the lower bound will change to x, so we also do the integral with lower bound x and upper bound infinite to the 1 over y squared, and we get the density functions of x equals to 1 over 2 times x to the power of 2. And we can write them together and draw the graph of density functions of x. And then we can use the same method to get the density functions of y. With the upper and the lower bound equals to y and 1 over y, which is given in the questions. So this part is easier than the part mentioned above. And then we can find that the density functions of y equals to ln y over y square, and also we draw the functions like we draw the graph of y, the density function y like this. The fourth part is to ask us to verify fx and fy are valid density functions. So if they are valid density functions, the integral of both will equals to 1. So we calculate them one by one. First, we calculate the integral of fx, which is equals to 1, which means fx is a valid density functions. And then we also do the integral of fy. In order to get the values, we need also use a substitute method to let t equals to ln y and y equals to e to the power of t. So we can rewrite these integral functions here and simply do some calculations, and finally we will have the integral of fy equals to 1, which means fy also a valid density functions. That's all. Thank you.